Humans have successfully landed on the lunar surface 6 times using technology from the 1960s. The last crewed mission to the moon was Apollo 17 in 1972, and we've not returned in over 50 years. However, a significant new discovery is about to change everything as humans prepare to go back to the moon. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. The Artemis program is a U.S. government-funded spaceflight initiative aimed at landing the first woman and the next man on the moon by 2024. This program marks the beginning of a new generation of lunar exploration and the establishment of Artemis Base Camp, which could be built on the moon by 2028. One potential site for the lunar base is Shackleton Crater, which is over 12 miles wide and 2 miles deep, about as deep as the Earth's oceans. Envision a massive lunar base inside the dark shadow of this crater. So why establish a lunar base, and what would its purposes be? The moon contains valuable resources such as gold, platinum, and other rare earth metals. Additionally, water is crucial for any off-world exploration. By splitting water into hydrogen and oxygen and then liquefying them, you get rocket fuel. A spacecraft from Earth could refuel in the moon's orbit or at the lunar base. Scientists suspect there may be water ice at the bottom of Shackleton Crater, though this has yet to be confirmed. The Artemis missions aim to answer this question definitively. If water ice is present, it could be a valuable resource. Water ice has also been found in other areas of the moon, with NASA estimating there could be 600 million to 1 billion metric tons of lunar ice available for harvesting. Effective mining of this ice could turn the moon into an interplanetary gas station for trips to Mars. However, many steps must be completed before we can build our lunar base. The Artemis program consists of 4 main components: the Space Launch System rocket, the most powerful rocket ever built, the Orion spacecraft, a lunar gateway that will continuously orbit the moon, and the Human Landing System, which will transport astronauts to the surface. These systems will operate together, with early Artemis missions focused on testing all components. If everything goes well, humans could be landing on the moon by 2024. There are 3 missions in the first phase. Artemis I will be a test flight of the SLS rocket and the Orion spacecraft with no crew, scheduled to fly in November 2021. The mission's primary goal is to ensure the spacecraft is safe for astronauts. It will also carry 13 small satellites for science and technology investigations. The Artemis II mission, set for 2022, will be the first crewed flight test, assessing whether Orion's critical life support systems are ready for longer duration missions. This mission will take 4 astronauts to lunar orbit, where they will spend 4 days before returning home. This will be the final preparation for Artemis III, which aims to land humans on the lunar surface in 2024. The Space Launch System has been in development since 2011 when NASA announced it as the future rocket for deep space exploration. It is the most powerful rocket ever built and, once operational, will be the most capable super heavy lift vehicle in the world. The SLS features 4 Aerojet Rocketdyne RS, 25 engines in its core stage, and 2 expandable Block 1 and Block 1B solid rocket boosters. The rocket's upper stage, responsible for putting the payload into orbit and towards its destination, is powered by the interim cryogenic propulsion stage, a modified second stage used in the Delta IV rockets. An additional exploration upper stage can be added for payloads beyond low Earth orbit. Standing at 364 feet, it is slightly taller than the Saturn V rocket and can deliver over 130 tons, or 286,600 pounds of payload to low Earth orbit. The Block 1 rockets will launch the first few Artemis missions, later upgraded to Block 1B and eventually Block 2, capable of taking the Orion spacecraft directly to the moon in a single launch and beyond. The Orion Multipurpose Crew Vehicle, MCV, is NASA's crewed spacecraft for deep space exploration. For the Artemis program, it will be the primary transport to the Moon and is also planned for missions to Mars. Built by Lockheed Martin, the Orion MCV includes the crew capsule, the service module, and the launch abort system. The crew capsule is designed to carry up to 6 astronauts, but will carry 4 on regular missions and will be the only part to return to Earth. Attached will be the European service module by Airbus Defence and Space, serving as the primary power and propulsion component until discarded at the end of each mission. A launch abort system atop the crew capsule can quickly eject it away from the main rocket during accidents, functioning like an ejection seat. During normal missions, after separating from the SLS outside Earth's atmosphere, Orion will fire its AJ-10 hypergolic rocket engine to enter lunar orbit. It can stay in space for 21 days undocked and up to 6 months docked. The Gateway is a critical component of the Artemis program, serving as a staging point for lunar surface exploration and future deep space missions. Once completed, it will be a fully functioning lunar space station with its own propulsion unit, solar-powered communication hub, science laboratory, habitation units, and docking ports for spacecraft, payload modules, and landers. It will act as a crew transfer facility, research platform, payload warehouse, and command center for lunar missions. The Lunar Gateway is a joint project involving NASA, the Canadian Space Agency, the European Space Agency, and the Japanese Aerospace Exploration Agency. The first piece, the power and propulsion element, is scheduled to launch in 2022. The habitation and logistics outpost will be assembled on Earth and launched into lunar orbit by 2023. More modules will be added, including a robotic arm, logistics module, airlocks for spacecraft, and a sample return vehicle. The Lunar Gateway will be smaller than the International Space Station, with 13% of the ISS's total pressurized volume, equivalent to a recreational vehicle's living space. Unlike the ISS, the Gateway will not be continuously crewed but will be inhabited at least once a year. Canadarm3, an AI-based robotics system, will manage the Gateway when uncrewed, operating science experiments. To transport astronauts from the Gateway to the lunar surface, the Artemis program includes the Human Landing System, featuring an integrated lander vehicle. NASA has chosen 3 U.S. companies to design and build these systems. Blue Origin's integrated lander vehicle will launch on the New Glenn rocket system and ULA Vulcan launch system. Dynetics Corporation is developing a single-structure human landing system for ascent and descent, launching on ULA's Vulcan system. SpaceX's modified Starship lunar lander, under testing, will launch on the Starship Super Heavy. The contract for these systems total approximately $968 million, forming the Artemis mission's backbone. Each lander has different capabilities in payload capacity, surface operations, mission duration, and survivability. After Phase 1, Phase 2 post-2024 will focus on sustainable lunar exploration, using the Gateway for research and surface trips. Science experiments in human physiology, space biology, astrophysics, heliophysics, and planetary science will begin. NASA and partners will develop Artemis Base Camp for extended surface expeditions. NASA's Viper lunar rover, set to land at the Moon's South Pole in late 2023, will conduct a 100-day mission searching for water ice and guiding resource harvesting for further exploration. The Artemis program will build lunar capabilities incrementally, preparing for Mars exploration. If all goes well, a fully functioning lunar base could be established within the next decade. This is an exciting development, promising to be fascinating as it unfolds. For the past 20 years, humans have continuously lived and worked on the International Space Station, preparing for deeper solar system exploration. Now is the time. Thank you for watching and see you next time.